Right, everybody. Assalamu alaikum. Glad you guys could make it. Glad everybody's here. Can you guys hear me nice and clear and loud? Am I loud? Am I loud? Am I loud? Yeah? Okay. All right, all right, all right. Awesome, awesome, awesome. So, what are we doing today? What are we doing today? Okay, so we left off at, okay, yeah. So we left off at the three-step method of solving mole question, right? That was the one thing we did, right? Everybody can solve that questions now, those kind of questions now. Today we're going to take a look at two different things. Okay, one of them being what you call it? One of them being volumes of gases, and the other being limiting reactants. Sometimes when they give us two things, and then we got to figure out which one reacts. Okay. So if you could just give me 1 minute. All right. Okay. Okay, you have that going. Okay. Okay. It shows me a loading screen. Well, there isn't a loading screen. I'm just starting now. Okay, so now, before we start, before we do the moles bit more, let's talk about, we're going to talk about volumes of gases. So there's a particular law of gases that we should be aware of. You might have heard of it. It's called the Avogadros Law. So I'm going to write it by hand. The Avogadros Law. Now, what does this law state? Well, the one part that we need to know for O levels in IGCSE is that at 25 degrees centigrade, a particular amount, 1 mole of molecules of a gas occupies 24,000 centimeter cube in volume, or known as 24 decimeter cube, where 1 decimeter is 10 centimeters, sorry, not 100 centimeters. Now at 25 degrees centigrade and 1 atmosphere pressure. So, and the funny thing is, it doesn't change from gas to gas. It is the same for all gases. Meaning, if I have 1 mole of CO2, its volume is 24 decimeter cube. And by the way, one thing you need to remember, so 1 decimeter cube is 1000 cm cube. Just like 1 decimeter is 1 decimeter is 10 centimeter. 1 decimeter cube is 1000 centimeter cube. And 1 decimeter cube in our everyday English is what we call a liter. So I'm sure you've heard the term liter. 1 liter is 1 decimeter cube. So in everyday English, 1 liter is 1 decimeter cube. So far, can you hear me? Yeah. And so if I have 24 liter bottles of carbon dioxide, it just means I have 1 mole of carbon dioxide. But 1 mole of oxygen will also be 24 decimeter cube. And 1 mole of hydrogen and these are, by the way, all measured at what we call RTP, room temperature of 25 degrees centigrade, and pressure of 1 atmosphere. It could also be applied to, let's say, let's get a different color now. 1 mole of methane, any gas, 1 mole of ammonia, any gas, as long as it's a gas, it'll occupy 24 dm cube. All right, that means any gas. It's a law that we know. It's that the amount, the size. So tomorrow, if I say, yaar, I have a container, let's say, and I tell you that this container's volume is 24 dm cube, and I put in oxygen in this, fill it up, and inside the container I tell you that the pressure is 1 atmosphere, and I tell you that the temperature I have measured is 25 degrees centigrade, also known as 298 Kelvin. If I tell you all these things, that the container is 24 liters, you can have a big ass container, its pressure inside the gas is 1 atmosphere, and the temperature is 25 degrees centigrade. Whatever gas that goes in here will be 1 mole of gas. If I fit in more than 1 mole, the pressure will increase. That's why for the volume that I can fit in this will be 1 atmosphere. Sorry, the volume I can fit, the amount of gas I can fit in this container, exact container, will be 1 mole if at 25 degrees centigrade and 1 atmosphere pressure. So gases occupy that natural volume. All right. Okay. Yeah. So now this is information that for every gas this is absolutely. I could have said, forget, screw oxygen. What about carbon dioxide? The same thing. Basically, if I tell you this, that okay, no, I don't have a container this much. I have a container whose volume is 48 dm cube. That's where the fun begins. If I have a container that has a gas, any gas, and the container's volume is 48 dm cube, and the temperature of gas is 25 degrees centigrade, and the pressure is 1 atmosphere. Remember, very specific conditions. So, no, that is Avogadros law. This is Avogadros constant. But yes, similarly, it can't be the same thing, but it's based on the same principle. So Avogadros, this is called Avogadros law. Constant is a number, law is an idea. Yes, Noman, I know you don't understand me, and I don't know how else to explain this. What I'm saying, and I continue to talk, is that the volume, if you don't know what volume is, then it becomes a little difficult. Gas occupies the space it's in. So if maybe it's easier to take this. Let's say I take 32 grams of oxygen. Now, how many moles is that? Well, 32 grams is mass over molar mass. And since the MR of O2 is 32, therefore 32 over 32, that means this is 1 mole. What that means is that if I take 32 grams of oxygen and I make sure its temperature is 25 degrees centigrade, I make sure the pressure, and if you don't know what pressure is in its units, then it's a little difficult asking me that you don't understand this, because if you don't know pressure, then that's a different ball game. But it's a number, it's a quantity of a quality of a gas, and I'm saying, okay, look, if I maintain pressure of 1 atmosphere and if I maintain temperature of 25 degrees centigrade, then if I let loose 32 grams of oxygen, the space the molecules occupy, the space the gas occupies, space being volume, will be 24,000 cm cube. That's a unit of volume, or 24 dm cube. That's what it means. So you take any mole of gas at 25 degrees centigrade, it will occupy this much. Very simply speaking, what we need to use it for is this. If I tell you that this is what I need to use, this is all you need to do. You need to know, if I tell you that I have 1 mole of gas, you will tell me, okay, its volume is 24 dm cube. If I say I have 2 moles of gas, you will say I have what volume? 48 dm cube. If I say I have 2 moles of carbon dioxide gas, you will tell me, okay, its volume is 48 dm cube. If you say I have 2 moles of CH4 gas, you will tell me it is 48 dm cube. Yeah. Well, if it's lagging for somebody, maybe it's your own internet. And because you see, if my internet was bad, it would lag for everybody. If your internet lags, then it would only lag for you. Get it? Because if you say my voice is lagging and 5 other people say my voice isn't lagging for them, it just simply means that my upload is pretty fine. Yeah, that would probably be it. If it's lagging, you can try YouTube also. This is being live streamed to YouTube also. Anyways, so that's what I have. Okay, now that's what we have going for us. So this is all we want to use it. What that means is, if I tell you that I have, instead of 1 mole, I have 0.1 mole of gas. What volume is this then? Well, 2.4 dm cube. If I have 0.01 mole of gas, I have 0.24 dm cube. Again, if you don't get any of this, all you gotta do is use a formula, Noman. All you got to do is use a formula. Just like for masses, you use the formula number of moles is equal to mass over molar mass. For each and every substance, we use this formula to convert moles to something else. For gases, we can use this formula, that the number of moles of a gas are the volume of gas divided by what we call molar gas volume, or 24 dm cube. Then the volume should be in the same units. Or if you like to use cm cube, then it becomes the volume of gas in cm cube over 24,000 cm cube. And that's literally all you have to use. So if I tell you that I have 60 cm cube, no, in fact, let's make it a little more interesting. I say that I have, let's say, 1.2 dm cube of SO2 gas. And how many moles is this? Well, simply 1.2 divided by 24. Well, you will know what formula to use in specific question. That's where my job comes in. You will know, Saad, in a few minutes. What is this? 12 over 24 is 0.5. This is 0.05. Not 0.04. Noor. 0.05. So, if the question says what mass, if it has grams, you will use this formula. If it says volume of gas, you will use this formula. So if I tell you, I'm giving you mass. So, for example, how do I know which formula to use when? Well, give me the moles of 16 grams of O2. And if I say, give me the moles of 1.8 dm cube of O2. Same gas. But what formula do you use where? If I see this, you will use number of moles is mass over which one? Molar mass. If I use volume, then I use the formula number of moles is volume over 24 decimeter cube. Does that answer your question, Saad? Data depends on the data in the question. Yeah? So, if you have this, what do we have? What do we have here? Yes, it's a. So what if I say, so how do I do this? Well, you first find the MR of O2. What is the MR of O2? It is 16 times 2. So the number of moles is 16 grams over 32. I get 0.5 moles if they give me that. But on the right isn't the same thing as something else. It is that they have given me the volume and I have to find the number of moles. So uske liye what I do, jo karta hu main, is take the volume and divide it by 24. It is, somebody tell me, 0.075 moles. It's a way of finding moles. Yes, absolutely, Saad. It means that if 12 dm cube of oxygen is 0.5 moles of oxygen and 12 dm cube of carbon dioxide is 0.5 moles of carbon dioxide. That is the beauty of this. It is the beauties of gases. Only and only for gases, eh? Do you guys understand? Show me by smiley face or sad face, huh? Do you get it? Do you understand or do you not? Yes. Thank you. Please be interactive. Yes, very good. Awesome. Yes. Okay, moving on to the next slide. Okay. Now, what is this? That Indian accent is top notch. I say top notch. What is up with that? So, how do I use it? How do I use this? I will tell you, because its good use is to, let's say, somebody says, okay, what is the volume of 0.01 moles of CO2? Let's say somebody said, please give me that. Again, the same formula. Number of moles is volume over 24 decimeter cube. The number of mole is 0.01. Volume you do not know, but you know is 24 dm cube. When you do this, what is V? V is 0.24, I believe, dm cube. It comes out to 240 cm cube. It is up to you. If the question does not say which unit you give it in, you can leave it in either or unit. Now, how did I do this conversion? Well, simply knowing that 1 dm cube is 1000 cm cube. So to convert from dm cube to cm cube, we just multiply by 1000. Yes. All right. It is okay, huh? Buran, it is good. Okay. How many people logged in abhi tak? Let us see. 22, 27. Oh my God. Welcome aboard, people. Welcome aboard. Is the thinner line better or the thicker line better? Oh, I am so glad, Mama. You have made my day. Okay. So, yes. Alrighty then. What is coming up next? Okay. So, what is up next? Yes. So now, what I would like to do is, one second. If you wait 1 second, okay. So this is how will I use this now. So when I do moles questions, there will be a use for that also. How? Remember, how do we do mole question? In a mole question, we have two things. We have an equation and we have data. The data is about two things, known and unknown. That is all it is about. And then it is three-step mechanism. And the three-step mechanism is step 1, step 2. You can solve every mole question like this. Every. But you will not be able to solve the question of life. But you will definitely be able to solve the question of chemistry. Which is that first convert the known quantity into moles. Then in step 2, what you will do is you will have the ratio between the known and the unknown from where? From the equation. And using then you will find the moles of unknown. Now, and the third step was to convert the moles of unknown to the physical quantity you desire. Now, earlier we only use one formula. Which one? That says number of moles is mass over molar mass. But that is if your data was given about mass. Now, if the data is given about volume of gases, you can use it to find that out. The moles also. So if you are given the volume of gas for something, you can find the moles for that. All right. Similarly, in step number 3, just like you can use the moles to find the mass, you can also use the volume, moles to find the volume of gas. So now you have the choice of two formulae. So the only thinking your little brain has to do is which formula to use. That is it. That is the maximum thinking your brain does. And so, yes. Yes. It is the energy levels are off the charts today, I tell you. I don't know why. Maybe it is the coffee I've had. Maybe was it the 7th cup of coffee or was it the 8th cup of coffee? I can't decide. It is the same method. The arrow is different. In step 1, you convert mass, which is or volume, to moles. In step 3, you convert the moles into mass or volume. All right. Drugs, yes, it's called caffeine, Burhan. Caffeine. It is available free, almost free in chai dhabas and in my coffee cup. Okay. Naman, my chill pills are very expensive, son. Okay, so let's use, Mama, we have done these 3 steps in the previous class also. Yes. So now let's apply all of this information. Let's take a beautiful question. It is beautiful because I love calcium carbonate, because I love the term limestone. Now let us tell you that I have calcium carbonate, and I know when I heat calcium carbonate, it gives me calcium oxide and carbon dioxide. Yes. Now, but in this equation, I am telling you the question. What volume of carbon dioxide at RTP is formed when 10 grams of calcium carbonate is heated? Okay, that is the question. Now, what is my known and what is my unknown? My 10 grams of calcium carbonate is my known. And what is my unknown? Volume of carbon dioxide is my unknown. Do you guys appreciate that? Do you guys, yeah? You guys follow? Us follow? Us follow? Yeah, yeah. So we will use both formulae. Hey Ramesh, what's up, dude? How you doing, son? Step 1. Step 1 is known. Known is calcium carbonate. I will commit myself to that. Uske liye, before I use the formula for mass, I know I will need the formula mass of CaCO3. What is the formula mass of CaCO3? It's 40 plus 12 plus 48, which is how much? 100, by the way. I will use the eraser. Okay. Now, then I will then use my beautiful formula. What is my formula? Number of moles is mass over molar mass. Are you now bored and tired of the formula? 10 over 100, which should give you 0.1 moles. Now that is the moles of what? Calcium carbonate. Well, as long as you are bored and not confused, I'll take a bored chemistry over confused chemistry. So now my known is calcium carbonate and my unknown is calcium oxide. And the ratio is what? 1:1, the coefficients. But I really have only 0.1 mole from the previous slide, right here. So how much of calcium carbon dioxide will I make? The ratio is 1:1. So that means what this means is this, that where do I point it to? There's no pointer. Oh my god. So what I just found is 0.1 moles of calcium carbonate will make me 0.1 moles of carbon dioxide. And if they wanted the moles of carbon dioxide, that is all I will need. But I will not stop there because I've been told to find the volume. So how do I find the volume? Come on, some more nicer colors. They don't have. They have orange. I don't think you can see orange also. What's the point of that color? I don't know. Okay. So now it says volume of CO2. Now because they wanted volume, the other formula is volume over 24. So I have 0.1 moles and I have 24 dm cube. So what is volume then? Do the math. 2.4 dm cube of CO2. And there you go. That is how you solve beautiful questions. Yes? 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 Yes. I'm going to take out a couple of more nice questions for you. Okay? You got to wait for a minute. Okay, 1 second. I have questions too. Well, honey, I didn't take. Well, if you want to do something easy, how about you do some sit-ups? You want to do O levels and you're bitching about tediousness. Well, no, I'm not repeating myself also. Okay. What? If I'm looking for a question now, 1 second. I'm opening it up. Okay. What? Yes. How? What? Then next up. Now. Okay, so now that's the kind of stuff. You'll also be able to get stuff like this. Okay, this is me asking you to do this. So what is the volume of 48 grams of oxygen gas at RTP? How do I do this? So you have again the thing that connects mass and moles is this formula. Number of moles is mass over molar mass and number of moles is volume over 24 dm cube. इससे पहले आप मोल्स निकालोगे और फिर आप वॉल्यूम निकालोगे. It says 36 dm cube है. 3 of you have gotten it right. How do I even, by the way, how do you guys do a break? I don't even know how to do a breakout session in this. Like I was trying to do this, I was trying to give you a question to do, but there's no way. How do you even do that? Like I know there's teams, but that's it. What do you do with the team? I don't know. Okay, screw it. All right. Yeah. Then I'm just looking at some questions as they're saved on my phone. So, yeah. Okay. All right. Okay. So let's say I give you a question like this. In fact, let's say this is the question. Okay. So now I'm saying what volume of CO2 at RTP is formed when 0.4 moles of C5H12 undergoes combustion. Now it's an equation and a reaction, right? So how does one do this? Well, there is the unknown, because it says right here what volume of CO2, and this is your known, and you have a 3-step process. 1, 2, 3. Step 1 known के moles निकालने हैं. Step 2 ratio from equation निकालना है. And step 3 unknown के moles को उसकी quantity में convert करना है. So first of all, you don't have to do the first part. Do you know why? Because what? Stalling? What is stalling? Yeah, moles are already there. How much is moles? So you already have that. It's 0.4 moles. Then the ratio in the equation is C5H12 is to, what is it? CO2. That is 1 and is to 5. So it would be 0.4 is to what? So what do you do that cross multiply and you, as Abul says, what does Abul say? Chrissy, crossy, crossy, Chrissy. How many moles is this? I'm sure some of you have done that. That's brilliant if some of you have done this. But crossy, crossy. Crossy, crossy. 5 into 0.4 is 2. So x comes out to 2. No? So when the moles is 2, then see 1 gives 5, 0.4 gives 2. So then you use this formula, which is, by the way, once you start doing it enough, it's not tedious. It actually can be done on a calculator then, without having to write it down. And so you do this, solve this, volume comes out to 48 dm cube. Yeah? It's already given to us. What is the confusion, Umama? You seem to have a lot of confusion. It's been going on for the last, I don't understand, everybody else. I don't think a single person didn't get it. Kind of everybody got it. It's already given to you. You know? Like, right? This is your information already given to you. आपको इसके moles दे दिए पहले से. You know? Maybe sometime reading the question might help. Okay. Yes, we will also do percentage by mass. We'll also do other things. Today, first, I'm looking at volumes of gas and questions like that. So making sure we have that covered. Okay. Now, okay, yes. So now let's combine the two questions. ठीक है ना? I have a question. Oh, what am I doing? Okay. Let's say I tell you that H2S, okay, reacts with 3 moles of oxygen, 2 moles of H2S, reacts with 3 moles of oxygen to form, actually my writing got bad, I'm not liking it. Let me write this again. 2 moles of H2S reacts with 3 moles of oxygen to make 2 moles of sulfur dioxide and 2 moles of water. Then the question is, what volume of SO2 gas is formed measured at RTP from burning, because anything that reacts with oxygen is called burning or combustion, from burning 48 dm cube of hydrogen sulfide. Now hydrogen sulfide, by the way, is H2S. That's what you should know. So now I've been given the equation and the question. So what do we have here? Yeah, this is the volume of CO2 and this is the volume of H2S. So that is my known, because that's given to me, and volume of SO2 is my unknown. Yeah, so I gotta do that. So volume of SO2 is unknown and volume of H2S is my known. Good for you, Burhan. Absolutely. Now there are 2 ways of doing this. First, I'll show you the one method that we've been doing so far, because I will do this in 3 steps. Step 1, step 2, step 3. Step 1 is for known. Known का क्या दिया हुआ है? 48 dm cube of H2S. जब गैस दी होती है उसके मोल निकालने के लिए एक ही फॉर्मूला है, Number of moles is volume over 24 dm cube. Do you follow? Yeah. So this would be number of moles is 48 over 24. How many moles of gas is this? 2 moles of gas. So basically 48 dm cube is 2 moles of gas. And the ratio from the equation is H2S becoming SO2. Their coefficients are 2:2. So, so the number of moles of SO2 I need are also 2 moles. Because वो 2:2 ratio निकल आया. Right? So 2 moles will make 2 moles. उसके बाद क्या पूछा गया है? The volume. So now SO2 का volume निकालना है. Which formula will I use? Again, volume के लिए एक ही formula है. Volume of gas के लिए. Volume of 24. So 2 moles, absolutely. This comes out to 48 dm cube. Now, I'm not saying that you have to show the working at all times, but आपके दिमाग में यही steps चलने चाहिए हैं. You can do this in your head. 48 is 2 moles, 2:2. So 2:2, 2 mole will make 2 mole. Okay, 2 moles का volume कितना है? 48 dm cube. Exactly. You follow this? Yeah? Now I want to look at a couple of the questions. I keep looking at my phone because I've got the questions saved on my phone. I can't look at my desktop. I'm teaching you there. The screen is being recorded. My iPad, I'm seeing what's happening on YouTube. So I've got to use this. All right. Okay. No, Abdul, the coefficients are only used in the ratio. Noman, I am an official YouTuber, by the way. I've got 5 million minutes watched. I've got 1 million views on my videos. If that doesn't make me official YouTuber, what does? Yeah? Yeah. Yeah. Absolutely. Anyway, so what will be the number of bonds produced in SO2? I don't understand even that question right now. What? I don't know. Okay. Yeah. Okay. Then so I'm going to give you a question. From not 800, let's say, from try this one out. Yeah, try this one out. Yup. Sounds about right. So it is 960. So let's find the first step. You have to divide the mass by molar mass. Now I'm going to start doing some shorter steps. The MR of N2 is 28. So the number of moles is 560 over 28. That comes up to 20 moles of N2. And N2 to NH3 coefficients are 1:2. Noman, you have big problems in life, it seems. Every second question comes out wrong or you don't get. While most of us are now, having done this tediously, are getting this right now. So I've got the moles of ammonia. Now Hamza, I have the moles of ammonia. What formula will I use? The volume formula, because I want the volume. So 40 divide this. When you cross multiply, you get volume of 960. Yep. Follow? Yeah? I know it seems tedious and you're getting this. Yeah? All right. Zahir, the number of bonds that you're asking me has got nothing to do with the mass of the molecule. The number of bonds has got to do with the bonding of the molecule. Okay, I'm glad. All right. Okay. Yes. All right, done. Now, okay. So now let's take it a little differently. Okay, let's say this. Let's say the same equation again. Okay. And I say, what volume of hydrogen will produce 120 centimeter cube of ammonia. Let's see if you can do that. Now I'm going to pause this here and ask you guys to do this one. All right. Yep. I said what volume of hydrogen will produce 120 cm cube of ammonia. The question is right there. What volume? What do you mean what? That's the question. The question is right there. The volume of hydrogen is the unknown and 120 cm cube of ammonia is the known. I don't know. How about you refresh your page? Can you guys Yeah. You can see the question on YouTube, by the way. Is there? Hmm? Somebody said 60. No, it's not 60. It's not 60. It's 180 cm cube. Or I think 180 cm cube is 0.18 dm cube. Yeah. Yep, Noor, you are absolutely right. Okay, it's okay. So now, should I do this? Well, then the first part is you gotta convert the 120. Now either you do it in dm cube, or if it's given in cm cube, you either can convert this into dm cube or use the cm cube formula, which is volume over 24,000 cm cube. So it's 120 over 24,000. That gives you what? Anybody have that? 120 over 24,000 is 0.005. 0.005 moles. And then the ratio is what? 3:2. So how many moles? 0.005. Cross multiply, you get 0.0075 moles. Exactly. Yes, Mason. Then the last thing is what? Is that you want to find the volume, right? So you can use that formula. If you do that, you get the answer in dm cube. So 1.0075 over v over 24. Now I believe that is 0.18. I'm just guess. 0.0075 into, what is it, 24? It's 0.18, yeah. 0.18 dm cube, which is about 180 cm cube, whichever way you want to leave the answer. That's how you do this. All right, that works. Yes, 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 yes. Okay, why do you hate yourself? Okay, I'm sure you can, but okay. All right, so yeah, that's the kind of stuff that we do. Okay, yeah. Now moving along, yeah, moving along. What is left? Okay, so this part is done. All right, Now, a couple of questions I have to give you still. 1 second, where is it? Okay, so things like I'm looking for a question. Okay, so let's say I have a certain volume of, let's say, okay, how do I erase this? I say I have as, let's say, 60 cm cube. Okay. Okay. No. So what I'm saying is, a certain volume of oxygen is 64 grams. What is the mass of the same volume of CO2? Now, it is not a 3-step question. It's not the same as that. It's no reactions, but we'll do writing equations later, Mason. Right now, I'm only concerned about the moles, but step by step. So here, I'm saying a certain volume of O2 has a certain mass. Same volume of CO2 का mass क्या होगा? Try this one out right now. All right. नहीं, सेम नहीं होगा साद. Good question. Let's see. Okay, so yep, it's 88. Yep. Awesome, guys. Yes, Burhan. Yep. So you first find the moles of oxygen. That's what you want to find. Hey, what suddenly happened to the writing tool? It seems to write a little better right now. In the middle of class, it seems. Number of moles is mass over molar mass. So 64 over 32, because oxygen is 32. That's 2 moles. So if they have 2 moles, when they say same volume, the trick is knowing the same volume means what? Same moles. And so if there's 2 moles of O2, what they mean is it's also 2 moles of CO2. Yeah? So now same moles का mass निकालना है. But MR of CO2 is 44. So 2 moles is mass over 44 grams. What do you get? Is 88 grams. Awesome. Yeah. Not 96 dm cube. Who asked for volume? Nobody asked for volume. I don't know what they're calculating. Yeah? Yeah? Okay, another one. Okay. So volume of 48 grams of ozone gas. This is ozone, a form of oxygen. Yeah. Yeah, I think we're done with this idea. It's simple stuff. I don't think anybody should worry about this more. Yeah, what do you say? Yep, because ozone's MR is what? 48. So the number of moles is 48 over 48. Oh my god, 1 mole. So basically, what's your vol? So 1 mole's volume is what? 24 dm cube. I mean, if you're doing the formula, this is what you do. But you don't need to do the formula. It is 24 dm cube. Yes? Alrighty then. So far so good? Yeah. I think this is enough, Noman. If you still can't do it, then God help you. Yeah, no. Screw that. I'm not doing any more on this. Even I'm tired of this. You know? Very well said, Bran. You can have fun on another time. Yeah. All right. Anyway, so what next? Okay, so you know what? 1.5 hours seems so long, by the way. you know, it's like, yeah. So one question, let's do this little trick. So let's say that I give you this again. From 2. Let's see you try this one. Yeah. Yeah, we'll after this I'll see if I'll let you go. Good for you. Yeah. Let's see you try this. Come on. Can we? Yes, Abdul. That's NH3. Yes, NH3. Yeah. N2 plus 3H2 plus 2NH3. Yeah. Yeah. For those of you got it, this is 4dm cube. Now, there are two ways of doing this question. The first is the long way. And this is the only time you can use a short current. Now, the long way is you take the nitrogen and first convert it into moles. 2/24. If I leave it as a fraction, it's 1/12. Right? Moles of nitrogen. Then nitrogen to ammonia ratio is 1:2. So 1/12 is to what? It's to 2/12, which is 1/6. I'm just leaving it as a fraction for now. And then the last bit was what? Is that ammonia ka volume nikalna hai. So you'll use the same formula, volume of 24, 1/6 is equal to volume over 24. You take 24 to the other side. So 24 over into 1/6 is volume, which is actually 4dm cube. Now this isn't that long to do, but there's even shorter way to do that. I'll show that to you. Now, what's the shorter way? So everybody got this way? Yeah? Talat has gotten it, Kate's gotten it. I'm glad. Those guys on YouTube. Yep, you guys gotten it here also. Awesome. All right. Now, what do we do? The other method is this, and this only and only applies to gases, and just take my word for it, is that for gases, mole ratio is the same as volume ratio, but only for gases. What that means is, in my formula, if it was N2 with 3H2 becoming 2 moles of ammonia N2 and ammonia ka ratio was 1 mole in the equation is to 2 mole, right? That's what we had, right? All I'm saying is for gases, yeah, okay, but it's not but just take, I just said don't ask me right now, I don't want to explain the why. It's to do with the fact that 1 mole of every gas is 24 dm cube. While I cannot say this for liquids and solids that 1 mole is always 10 grams. For each compound 1 mole is different mass, but for all gases 1 mole is 24 dm cube. Now what I'm saying is that 1 mole is to 2 mole is the same as 1 dm cube is to 2 dm cube, or 1 cm cube is to 2 cm cube, is what I'm saying. Now I'll explain why and how in a minute, but let's say I told you this. How could you have used this? Yeah. Hi, I was asking you guys, anybody here alive left? I know it's a bull, it's getting too late, but yeah, anybody alive left? Yeah. Yes. So how could I use this? So in the previous question, if you saw, I said what volume of ammonia is made from 2 dm cube of nitrogen. So if I have 2 dm cube of nitrogen, what was the shorter way? 1. So I could use this relationship. If 1 mole is to 2 moles, 1 dm cube is to 2 dm cube. So if 1 dm is to 2 dm cube, 2 dm cube would be is to how much volume? That's literally what I would do. I would take the formula equation again, and I would see the ratio is ratio is 1 is to 2. It's just like saying 1 dm cube will give me 2 dm cube. So 2 dm cube will give me how much? 4 dm cube, which is the answer we had gotten earlier, remember? And you can use this for any gas, but only gases, when only both of them are gases. Yeah. Yes, you can use either or. You can use either or. I'll tell you where this comes in handy. Let me show you. You know where it comes in handy? In a question that you might have not seen done, Abhina. So that will maybe make it seem, it's just simple. Once you get the hang of it, it is very easy. Let's say I give the formula CuO plus 2 ammonias react, and I'm giving you the equation 3 coppers and nitrogen and 3 hydrogens. And the question says this. The question says I have 1 dm cube ammonia and I want the volume of nitrogen. I want. Now, I mean, one way is the 3-step way, which is absolutely correct. Okay, but now, so look, simply speaking, how does one do this? This is the last thing I'm doing. So ammonia is to nitrogen. Their coefficients are 2:1. So you can even use it for volume. So 2 dm cube is for 1 dm cube. So 1 dm cube is to what? And crossy, and you get x as 0.5 dm cube. But you can use the long method too. Is that okay, guys? Yeah? All right. Okay, so you can use both formula. This is just a shorter way of doing this. It just comes in handy doing gas questions faster. Okay. All right, so let's do this. So now that we've done a big chunk of it, a good idea of volume of gases, okay, and moles, we have conquered this, yeah? And I shall now see you guys on Tuesday. Okay, let me write that again. Tuesday at 5 p.m. on Zoom and YouTube Live. All right. Okay, I'm gonna head out now. All right. Khuda Hafiz, everybody. Now, enjoy your day. Khuda Hafiz. Khuda Hafiz. Yep.